Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today we will go to part 2 about how to link the data from PLC S7-300 to PLC GE by using the Profibus Master and Profibus Slave linked together. Okay. In the previous video, we already learned about how to create the text and create the link from Proficy Machine Edition and Simplicity link to Semantic Manager and Business Flexible. And we also tested with the status. If we send data from PLC GE to PLC S7-300, we can control and it will feedback the signal to PLC GE. Okay. So it just use about the byte memory. So today I will show how to link via use the word memory, yes, with the analog, and then we can convert from word to byte also bit, and then we will test together. Okay. So here is the diagram overview of this testing. So I have one switch, Ethernet switch, that link or connect from my PC to the CPE port number 1, and one more port of switch I will link to PLC S7-300 for download the program. Okay. And I have Profibus cable, yeah, that link from Profibus Master from PLC GE connect by Profinet scanner and connect to Profibus Slave part of PLC S7-300 CPU 314C 2PN/DP. Okay. So let's go to create more or add more memory for word. Okay. And I will explain step by step about how to convert from word memory to byte and then test together. Okay, so let's go. So first let's open Proficy Machine Edition to check our existing project that we already learned in the previous video. Make sure we can connect to the CPU and we can online before we start to add one more memory word. Okay. So in the previous project is PLC S7, right? So let's open. Okay, and then let's test online. Because right now I already turned on power to PLC. Okay, so right now we can online. Okay, and let's see the data. Existing data is still have, right? So we will assign the memory, yes. So to assign the memory, let's go to our Profinet port. I will assign the memory to this slave more, yes. Last time we have only 2, right? With byte memory, yes. Master I slave Q, it means that PLC GE is input and PLC S7-300 is output, and for 8 byte more master Q slave I, it means that PLC GE is output and PLC S7-300 is input. Okay, so to add one more memory or another memory, let's go here, configure, and then go to the module, yes, and then click add to add one more memory or another memory. So example, I will add 1 word, yes, or 2 word, yes. Let me add 2 word, queue, slave queue, sorry, master I slave queue for 2 word, okay. And I will add 2 word more for master queue slave I, yes, okay. Master queue slave I 2 word more, and then click OK, right? The address will generate automatically. Example for master I, it will start from AI20, yes, and for master Q it will start from %AQ5, yes, okay. So save the project, and then we need to download to the CPU, right? So before download to the CPU, let's go to Semantic Manager, yes, open Semantic Manager, because we need to add the more memory to the slave also, right? Slave CPU, yeah. So let's go to hardware configuration, and then go to the DP setting, and go to configuration, yes. We need to add more memory, right? So example, we can create new, and let's see here, master I slave Q, right? So slave should be output, okay. So we will add output, and the length is 2 word, right? So select 2 word and click OK. So the address will generate automatically, yes, okay. Start from O, yeah, or Q8, right? Okay. And we need to add one more, right, for master Q slave I. So it means that input for slave CPU. So new, and then input, yes, and the length is 2 word, and select all, yes, and then click OK. The memory address will generate automatically also, okay. Okay, and then save the project, and we can ping to the CPU, otherwise we cannot download, right? So test 192.168.0.1, okay. It is the address of CPU, so we can download the hardware configuration. So wait a moment for downloading. So wait a moment. It will detect automatically for the CPU because we had ping. Yes. So let's view to view the CPU. Okay, it found one CPU, 192.168.0.1. So click OK to download, and then restart the CPU after download. And I will show the status. Right now the communication is not okay, right? Because we just add memory. So we need to download to the PLC GE also. Okay, let me show the status. Okay, let's see the status is not okay. Let's see here. It fall because the memory between slave and master is not So we need download to the PLC GE, yeah, to this CPU. Yes. Okay. So let's download. So download, connect to CPU, and then I will stop the CPU because we download the hardware configuration, right? And then download. I will show the status after download. Okay, downloading now. Write to flash. Okay, and then I will start the CPU. After start the CPU, let's see here. The status is okay, yes, no alarm. It means that the communication between master and slave is okay. Okay. So we can write the logic to test communication. Yeah. Send the data and receive the data. Okay. So to create the data, yes, we need to convert from the word to byte, right? Okay. So I will convert the PLC S7-300 first. Okay. Example, we would like to send, right? Or receive the data from the PLC GE, right? So first let's check here. Yes. If we would like to get data from PLC GE, we must use the IH, right? Okay. So example, got data from PLC GE. So we can use the function move. Okay. And then move input, right? So right now input is start from H, right? Here, IH. So I can write IH. Sorry, PIWH. And then here is the memory that we will assign. Example, I will assign with IW1000. Yes. Okay, IW1000. So if like this, we can convert to byte to bit, right? Okay. Example, the bit number 1. Let me insert one more network. Example, bit number 1. Bit 1. We can write I1000 dot 0. And then example, to control the output, right? Example, to on the output. Last time we have used the Q136.0, right? So right now I will use Q136.0. 136.1. Okay, and then if we would like to feed back to the PLC GE, we can use we can copy and paste. Example Q0.1. Yes, it is the feedback signal to the PLC GE. Yes, and for bit number 2, we can also create it. Example bit number 2. Okay, bit 2, we can start from I 1000.1, right? And then control the output Q136.2, right? And then the feedback is Q0.2, right? Okay, we can test only 2 bits. Okay, can download and then online. Yes, right now the input is out, right? Okay, because the PIWH is 0. So we need to go to the Proficy machine edition to convert also, right? Before test. So let's go. Okay, main program. I will offline first, and then go to the main. And here we need to convert from binary to decimal, right? Okay, let me comment a little bit. Example, send data to PLC S7-300 CPU 314C 2PN/DP. Okay, and we need to convert from binary to decimal, right? Okay, so binary to decimal, right? Here we can use the function block. Yes, for convert. I will create the function block. Send to S7. I will import to the main. Yes, and then double click here. We will use the function binary to decimal. Yes. Okay, I will adjust a little bit for dimension. Okay, so we can use the binary to decimal, right? This function. Yes, enter. Okay, I will change the height to be 50. Yes. Okay, then the default is 0 for CMP, and here is the set file. Yes, set file 35. It is the default. Yes, we can check the manual operation of convert from binary to decimal. Yes. And for the output, we will put the %AQ. Yeah. Let's check here. It is the output, right? We would like to send. Yeah, here. So it will start from %AQ file. Yeah. So I will put here %AQ file. Okay. And then we can write bit 1 until bit 16, right? Because we have 16 bits for one word. So we can write bit 1 for input, right? Bit 1 until bit 15, right? Bit 2, you can validate. Error 1, right? Because we need to put the input, yeah, until bit 15. So I will drag and drop copy first, and then let's change the name later. Okay, good. So this one should be bit 3, right? Bit 3, bit 4, bit 5, bit 6, bit 7, bit 8, bit 9, bit 10, bit 11, bit 12, bit 13, bit 14, bit 15, and bit 16, because we have 16 bit for one word. Yes. Okay, so let's save the logic and then we can download. Yes. Okay, download. Okay, good. Right now we already download. Yes. So we need to test, right? So I will zoom a little bit for test. Communication is working or not. Yes. Let's test together. Sorry, my computer is slow a little bit, so I'm also sorry. Okay, so let's check here. Yes. So if I would like to force the signal, example, I force turn on. Yeah, turn on pung here. Let's see, this one, right? But this one not work. Oh, okay. I confused this one. Sorry. We need to use the bit, right? 1001.1 1.0, right? Because it will swap, yeah, the word. So let me change this one to 101, 1001.0. Yeah, sorry, forgot to convert sweep, right? It will sweep. So download again. Let's see, the bit is on, yes. Because we need to go to swap the word, yeah, from right to left, from left to right, right? Because we convert from word to bit, yeah. Let me for the point number 1, sorry, number 2 is turned on, yeah. Let's see, the signal is turned on also. So if we would like to force the signal number 9, right? It should be 1000.0, right? So let me create, because we need to swap the word. Okay, let me edit more, insert network, and then example bit 9. Yes, bit number 9, right? So bit number 9, it should be start from I 1000.0, right? Example start the bit this one, example Q 161.0, right? Because it 8 bit the same, yes. And then for this one we can write okay, Q 1.0, right? Okay, for feedback. So we can save and we can download. Yeah. So if I force the signal bit number 9, let's see here. Okay, it will work. So let's edit more. Insert network for bit 10, right? And then we can use the input I1000.1, right? For bit 10. And then Q 161 dot, sorry, it is 130 137.0, right? This one also Q 137.1, yes. And for feedback we can write Q 1.1, right? Okay, you can download. So if I force signal for bit 10, yes, I force on bit 10, it will work also. Okay, turn on. And let's see the feedback on the PLC GE. Yes, feedback. Let's go to I/O table, right, to see the feedback. Yes, let's see here. The input is turned on also, right? Okay. For bit 10, bit 9 and bit 10 is turned on also. So the communication is okay. So here is very important that we can convert from binary to decimal. Yes, here. Okay, and this is the default number. Yeah, so we will must follow like this. It will work. Okay, so if I would like to remove force off, yeah, it will turn off. Remove force off also. Yes, turn off, and then remove force. From bit number 9, yeah, we can also turn off. Force off, yes, turn off. Remove force, one more. Force off and remove force. Okay, so we can use 16 bits of this signal for one word. For another word, we can also convert. Yes, example, I would like to convert for word number 2, because we add 2 words, right? Here, 2 words. So if I would like to convert word number 2, we can also binary to decimal also, right? Okay. And here we must put %AQ6, right? %AQ6. Yes. And don't forget put here is this the number, default number. Yes. So 6 5 5 35. Okay. And here example we can write word 2 bit 1. Yes, and we can copy until 16, right? So we just change only bit 1 until bit 16. Okay, so I will change this one to bit 2, word 2 bit 2, word 2 bit 3, word 2 bit 4, word 2 bit 5, word 2 bit 6, word 2 bit 7, word 2 bit 8, word 2 bit 9, word 2 bit 10, word 2 bit 11, word 2 bit 12, word 2 bit 13, word 2 bit 14, word 2 bit 15, and word 2 bit 16. Okay, then we can save the project and then download. Yes. Okay, download. Okay, download successfully, and then we can config on the PLC S7-300 also, right? So let me offline first, and then go to insert the network. Example, got data from PLC GE word 2, right? So we can also use move, and then move PIW, right? So PIW 10, okay, and then IW, example IW this one 1000, right? Okay, 1000. Example IW 1000, yes. Sorry, 1001 is already used, right? 1002. Okay. And then we can download. The CPU was stopped, right? So we need to download the block also, right? Okay. Right now the CPU is running. So we can test again. Okay. And then we can go to PLC GE, and then we can force signal to see the signal. If I turn on, yes, force on, let's see here is 1. So we can convert to bits also, right? Okay, example, I will convert to bit. So word 1, word 2, bit 1, right? Okay, word 2, bit 1. So I can use NO contact, and then it will start from I100, sorry, 1002 is bit 9, right? So 1003.0, right? Bit number 1. Example, I will turn on the position M. Yeah, example or person Q. Yeah, example person Q 137.2. Yes. Okay. And then let's test it on, right? Okay, it turned on right now. So for bit number 2, we can also do the same. Yes, word 2, bit 2, right? Okay, so we can use I1003.1, right? And for the output, we can use Q137.3. Yes, like this. We can download and see the status. So if I force signal for turn on the bit number 2, yes, let's see, bit number 2 is turned on also. Okay. If I remove force, I will force off. Yeah, for bit number 1, it will turn off also. Okay. So for bit number 9, yeah, And number 10, yes, I will show to finish this step. Example word 2 bit 9, right? So what is the address? So 1002.0, right? Because we must flip from left to right, low to high, high to low. So I will turn on the Q137.4, yeah, something, yeah. And then we can save. And one more example, word 2 bit 10, right? Word 2 bit 10. So we can use input I1002.1, right? And then turn on the Q137.5. Okay. Can online, yeah, to see the status. So if I force on bit number 9 here, okay, it's on. Bit number 10 here, it's on also, okay. So the signal is work properly between PLC GE to PLC S7-300, okay. So the next step, we will create the screen for control by through this block to this block, okay. And in the next video, I will show the more function of analog, yes. Example, we can send signal from PLC S7-300 to show on the PLC GE, and then we will create the screen to show also, right? Okay. Okay, so I will remove the false signal, yes, here. So false off and remove false off, remove false, and false off and remove false, okay. So we can send the signal from this one to control the PLC S7-300 by create the HMI, right? So let's go to create the HMI. So let's open the Simplicity Workbench, and then create a new project. Example, link GE to S7, or the project is long, so I will choose GE to S7. Then we can choose the driver. Yes, I will choose the driver. Yes, this driver. And then I will create the new port. Start from port 0. And then I will create a new device. Example, PLC 1 or HMI 1. And then we will put the IP address, right? So 192.168.0.100. Yes, and then we can start the project. It is very important for link from the GE brand to another brand, yes, to control. Example S7-200 or 300. So we can control and got the data back from the S7 to GE also, right? Okay, the device is up. So we can create the points, right? So before create the point, let's go to enable this one. Example, I will create the project. Yeah, see the logic for control from the HMI to PLC S7-300. So let's go to the main program. Okay, I will disconnect and then create the logic. So example, command start and stop from start and stop control from PLC GE to PLC S7-300. Okay. Example, I will create the NC contact for stop. Okay, stop HMI 1 and NO contact for start HMI 1 and send to this one, right? Okay, I will send to this one. So I can copy this bit, yes, to control this bit, and then I will hold the signal. Yes. So when we push start from the HMI, this bit will on and then send data to the PLC S7-300, right? Okay, I will put %M. Okay. And then I will download. Okay. So we can test. So I will create the new points. Okay, so I can create the new points. It is the boolean, right? Example, stop HMI 1. So %M4, right? This one. %M4. And for start, so start HMI 1, right? And then %M5. Yes. Okay, so we can create the screen. And for the feedback from this one, we can also insert the address, right? Example, %m 5, %m6, right? So we can also create the %m6. This one should be HMI1 signal, right? %m6. Okay, then I will download again. Okay, so we can create the screen for test. Okay, I will choose the motor, the same as the previous video, and create the start and stop button. Okay, one more for start. And then we can arrange, yes, and this one should be blue, right? Okay, and then I will create one more string, example motor 1. Or we can change another color that we want. Yes, I will use this color. And for feedback from the PLC S7-300, okay, I will use the feedback, right? Feedback. This one start the motor, right? So for feedback, let's check the hardware. For feedback should be O, right? OQ O 0.0, Q 0.1, right? Q 0.1 is already used. So I will feedback Q 0.1, yes. So for Q 0.1, we can check the address here. So master I, right here. So 161 percent I 161 already used, right? So for the feedback, we will vary with the hold the signal. So example, percent I 162, right? It is the bit number 2, yeah, feedback. Okay. And then we can test. Okay, I will add one more for feedback. So create one more point. Or we can use this point. Percent M, right? Percent I 162. Yes, feedback from the PLC S7. And then we can create the command start and status, right? So go to color animation. Yes, I will choose none. Go to color animation and then browse the point that we already created. So this is a HMI signal. Yes, so I will choose the green color when the feedback is okay. And for button start and stop, okay, I will adjust the font, decrease a little bit to be 24. Yeah, it's okay. So button stop, we can go to mount up, new procedure, new absolute set point, browse the point. So the stop, right, set to 0, and new procedure, mount down. Absolute set point stop to 1, right? Okay. And for start is the same procedure, so mount up, new procedure, absolute set point, start, right? So set to 0, and we can copy, new event, mount down, new procedure, new, set to 1, right? Okay. And we can save the screen, example screen 1. Okay. And then we can test. So if I push start, let's see, the signal is sent to PLC S7-300, right? But the feedback from PLC S7-300 is not work. So let me download, because right now the CPU is stopped, right? So let me download all program to the CPU again. Okay, so right now the CPU is running. Yes, then we can test. Okay, I will adjust to be easy to see the overall. Yes. So I will parallel with the bit, with this bit, right? So let's test first. Okay, when I push start, let's see the feedback is not come, right? Because the person Q, yeah, 0.1 is not turned on. So if we would like to turn on, we can use this Q, yes, this output. I will delete from this one. We can control H and then paste here. Control Z. Let's test again. This one, right? Okay, this one. So we can copy, or we can cut from here and then paste here. Okay, and then download. So when we push start, let's see the signal is feedback from the PLC S7-300, right? Push stop, push start again, yes. So this one is turned on, and then the person I, yes, person I here, that we already config here, is turned on, right? Yes. Person I 162, yeah, because 161 we already use, right? We already use here from the button start and stop. So if I push start and stop the existing project, it will turn on also, right? Let's see here, if I push start, yes, the existing is turned on, right? Existing program here. And if we would like to synchronize with other point of output here, we can do also. Okay, and we show. Example, we can control, yes, from this one. this output, right? If I push stop, it will stop. Push start again, it will start again. Okay. So for digital by memory, we can link. Yes. So if we would like to link the analog, we can add more memory for link, right? Let me show. So I will disconnect first. Example, if we would like to connect the sensor to PLC S7-300, yes, we can also show the status on PLC GE also. Okay, so let me add more memory. So to add more memory, let's go to the Profibus Slave here and then click config. Yes, and then go to the module, and then if we would like to add example I add 8 word more. So master I 8 word, right? Master I 8 word. Yes, here. Yes, it will come here, and then the address will automatically generate. Yeah, it will start from %AI22. Yes. So let me download. Okay, we will stop the CPU because we download the hardware configuration. Okay, I will show the connect the temperature and show on the status on the HMI. Yes, by connect from the PLC S7. So wait a moment for downloading the project. Okay, and then I will start the CPU, and then let's go to the PLC S7-300, right? I will close this one first, and then go to the hardware, go to the DP, yes, go to the configuration, and then add new for output, right? Because we need to send the signal to PLC S7, PLC GE, right? So I will choose output 8 word. Then click OK. The address will automatically generate for us. And then save the hardware configuration and then download to the PLC S7-300. So wait a moment for downloading. Okay. Yes. Right now we already download, and I will send the signal from the analog from this module. Example, I will send the PT100, yes, and send the signal 4Y, yes. Okay, to the PLC GE. So let's go to block, right? Create the logic. So insert the network. Example, send the analog signal from PLC S7-300 to PLC GE. Okay. And then I will use the address, right? Yes, the address. So the address will start from PIW256 for the PT100 or RTD, right? But right now I will use the PIW264, yeah, and then to send to the PLC GE, yes. We can online and monitor before we create, because right now I already connected the PT100 and RTD to the PLC S7-300 module here. Yes. So we can online to monitor. Example, PIW 256, PIW 258, sorry, PIW 258, PIW 260, PIW 262, PIW 268, sorry, 64, PIW 266, PIW 270, sorry, 268, right? And PIW 270, okay, because we have 8 channels, yeah. Then we can online and we can monitor as decimal, yeah. So right now I already insert the PT100, yeah, it's so around 26 degrees Celsius, yeah. And for the analog, yes, analog signal 4 to 20 milliamp, right? I will insert the standard source loop. Okay, and then I will adjust. Okay, let's see the signal here, yeah. So right now I will use PIW256 and PIW266, yes, to send data to the PLC GE, right? So first we can write move, yes. So I will send PIW 256, right? This one, yes, 256 from the PLC S7 to the PLC GE, right? So we will use the address here. Yeah, we will use the address because we already configure on the PLC. Yes. So I will use QW12. Yes, QW12. Yes, start from 12, right? So we can use QW12. Yes. And for another channel, we can use the PIW266, right? So this one for PT100. PT100, and for this one we can copy for signal 4 to 20 milliamp. For 20 milliamp, right? So we can use more move and move PIW266, right? 266 to XUW we can type QW14. Yes, and then we can download. And we can online. Yes, and we can monitor as decimal. Yes. So let's check the signal on the PLC GE. Yes, because right now we already send the PT100 signal and 4 to 20 milliamp signal to the PLC GE. Yes. So let's check the AI22, right? Okay. So let's go to check the AI22. So go to the table and then write %AI22. Okay. We will got the data the same as the PLC Siemens send. Yes. Let's see here. So if I adjust the standard source loop for 220 milliamp, yeah, let me show. I will adjust. Okay, so if I adjust the milliamp, yeah, I will adjust. Okay, I will adjust the milliamp. Let's see the raw value is changed also. Yes. 20 milliamp around 27,000. Yes. And I will hit the sensor. Yes. PT100. And then let's see the status is changed also. Yes. Because right now I already connected the PT100 to this channel. Yes, to this channel. So let me hit. Let's see the signal is start increase, right? I will increase hit more. Yes. right now around 68 degrees Celsius, right? So if we would like to use this signal to show on PLC GE, we can also create the block, yes. So AI22, right? It is the temperature. So let's go to blocks. So we can write divide real, right? Example percent AI 22 divided by 10.0, right? So we need to convert from integer to double integer. Sorry, double integer to real, right? So integer to real. This one, and then we can use like this. And let's check. Yeah, it is real. So we will got the actual temperature, right? Example actual PT 100, and we can choose the percent R. Yes. And then we can download. Okay. So right now the value, the actual is around 39 degrees Celsius, right? So if we would like to show this signal on the HMI, yes, we can also use this percent R, yeah, to show. So percent R1, I will create one more points. So it is the analog, right? So example PT 100. Sensor 1. So it is the real, right? And percent R1. Okay, we will got like this. Okay, we will got 38 degrees Celsius. So we can use the text. Let's go to screen and then edit. Example temp winding of motor. So we can use the rectangle, yes. This one should be white color, right? Okay. And then I will choose the text string, green color, right? So we can use the points that we just created. Yeah, this one. and it is the real, right? And if we would like to put the precision, yeah, decimal, example I put 1 decimal, so we can arrange to be center, yes. And if we would like to show the status, yeah, so right now around 31 degrees Celsius, so I will put the unit also. And the color should be, I will change to yellow color and adjust this font to be smaller than this, 18. And we can group, yes. So example, the temp winding motor is show signal also from the PLC S7, yes. So if I push start, yes, the motor is running and the temperature should be increased, right? I will hit, yes, when I hit the PT100, the motor will increase the temperature, right? Okay. I will hit more. Okay. 75 degrees Celsius, yes, for temperature of motor, yes. So this is just example about how to create the Profibus memory, yeah, that link from Profibus Master of PLC GE to Profibus Slave of PLC S7-300 by using the Profibus cable, yes. So I hope this video is so long, but I would like to explain step by step about how to configure and how to test, how to create the text or create the feedback memory from PLC S7-300 to PLC GE and control from PLC GE to PLC S7-300. Okay. So if I have a mistake in this video, I would like to say I'm sorry. Yeah. I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again and see you next videos. Bye bye.